Derivatives and rates of change, Part 5. Recall that the tangent line to the curve y is equal to f of x at the point P, a f of a, is the line through P with a slope m is equal to one of these guys. And also recall that the derivative f prime of x is equal to the slope of that tangent line. So if you're asked to find the derivative or find f prime of x, you can use one of these definitions. So if you're asked to find f prime of a for f of x is equal to 1 over 2x minus 1, we need to find f prime of x and then substitute in a. So f prime of x is equal to the limit as h approaches 0 of, since this is a rather tall function, I'm going to write my 1 over h, so that's the division by h first, in its own little fraction. And then I have f of x plus h, so that'll be 1 over 2 times x plus h minus 1 minus f of x, so 1 over 2x minus 1, and then all over h, which I already wrote at the beginning. And now I need to start trying to simplify this so that I don't end up with 0 over 0. So let's take a look here. I have two rational expressions, so a good bet is to combine these rational expressions. So I'll need to find a common denominator. So this is equal to the limit as h approaches 0 of 1 over h times 1 over, I'm going to distribute this 2 in this step as well, so I have 2x plus 2h minus 1 times 2x minus 1 over 2x minus 1 minus 1 over 2x minus 1 times 2x plus 2h minus 1 over 2x plus 2h minus 1, so that I find that common denominator. And this is equal to the limit as h approaches 0 of 1 over h times 2x minus 1 minus 2x plus 2h minus 1 all over 2x plus 2h minus 1 times 2x minus 1, my common denominator. And now I'll have some terms that subtract out. So 2x minus 2x is 0, and negative 1 minus negative 1 is also 0. So I have that this is equal to the limit as h approaches 0 of 1 over h times negative 2h, almost lost my 2, all over 2x plus 2h minus 1 times 2x minus 1. I'm out of space. Creating a little more space now, we can do some more simplification. We have a factor of h in the denominator and a factor of h in the numerator, so they will divide out. And we have that f prime of x is equal to the limit as h approaches 0 of negative 2 all over 2x plus 2h minus 1 times 2x minus 1. And now h is approaching 0, so I can substitute 0 in for my h's. And this is equal to negative 2 all over 2x plus 0, so that's just 2x, minus 1 times 2x minus 1. So that'll be negative 2 over the quantity 2x minus 1 squared. And that's f prime of x, but our goal is to find f prime of a. So I need to substitute a into my derivative. So f prime of a will be equal to negative 2 over 2a minus 1 squared.